This film is copyright GJS Science Education Consultant. If you want further copies, please contact gary.skinner1@blueyonder.co.uk. Enzyme concentrations and enzyme activity. In this experiment we're going to look at the digestion of a 1% protein solution made from milk powder Marvel by a 5% protease enzyme solution. The 1% protein solution is placed into a colorimeter cuvette. You can see it's quite cloudy. And then the 5% protease enzyme is also placed in the cuvette, equal volumes of each. The cuvette is then placed in the cuvette holder of a colorimeter and the clock is started. The colorimeter reading at the moment is 0.82, just fluctuating between 0.82 and 0.83. These are absorbance units. In other words, a measure of how much of the light the cloudy solution is absorbing. As the protease enzyme digests the protein in the milk powder, it becomes less cloudy, and you can see the reading going down. After 35 seconds the reading was down to 0.76 units. We will run this experiment for 5 minutes, and you should take readings every so often, once every 30 seconds or so is recommended. Just make sure that you keep a record of the exact time that the reading was taken. What you can then do is plot a graph of the reading on the colorimeter, absorbance units, on the y-axis, against the time since the beginning of the experiment on the x-axis. This graph will have a straight line portion due to the fact that the substrate is in excess. That is the milk powder, or the protein in the milk powder. However, once the amount of protein in the milk powder reaches a lower value, the speed of the reaction, rate of the reaction, will start to level off and the graph will become non-linear. For the experiment, you need to know what is referred to as the initial rate, and this is given by measuring the gradient of the straight line part of the graph. The experiment that we've set up here is designed to look at the effect of different concentrations of the enzyme on the initial rate of this reaction. And so we have to repeat what you're seeing now for each concentration of enzyme, get a graph of time against absorbance reading for each concentration of enzyme. From each of those graphs, get the gradient of the straight line portion of the line, which gives the initial rate, and then finally plot those initial rates against enzyme concentration on a final graph. The film that you're watching will take you through each of 5 enzyme concentrations, including the one that you're currently looking at, 5%, and then at the end we'll show you the 5 graphs of each of those concentrations, and finally a graph of concentration against initial rate. 2.5% protease solution. Starting reading this time is 0.68. Remember that it doesn't really matter what the starting reading is, because it's a question of the initial rate of reaction. In actual fact, the substrate concentration used was the same each time, so variations in starting reading are due to vagaries of the colorimeter. Plus 1% protease enzyme solution. Starting reading this time is 1.31. 2% protease enzyme solution. Notice that the protease enzyme solutions have not been put together in order. You need to do that. This time the starting reading is 0.93. With these final few enzyme concentrations, you'll notice that the time period has been edited out so that you just see what's happening every 30 seconds. This saves time watching the film. .3% protease enzyme solution. Starting reading 1.03. Coming up soon in the film, at the end of this last sequence, will be the 5 graphs promised. The equation for the line is given in the top right hand corner of each graph, and the figure in front of the x in the equation for a straight line y equals mx plus c, the figure m in other words, is the gradient of the line. It's a very tiny figure and negative because the graph is sloping to the right. It needs to be multiplied by 1000. And this will then give a manageable number for the y-axis. So the y-axis is the rate figure multiplied by 1000. So here's the straight line portion of the graph for 1% enzyme solution. The gradient is given by minus 0.0003. 2% minus 0.0007. 2.5% minus 0.0006, 3% minus 0.002, 5% minus 0.0017. And now a graph of the enzyme concentration on the x-axis, 1, 2, 3, 4, 5, and the rate